Okay, yesterday in class on November 13th, we talked about how to find a residual. So this is the goal right here. I can calculate a residual. What we did is we started with an X column and a Y column. For each X value, there's an observed Y value. The next thing that we did is we said we need to figure out the predicted value. To figure out the predicted value, you take each X value, so X is 5, and you plug it into the equation, 0.5 times 5. So 0.5 times 5 is 2.5, and you write that right there. Again, you do it for 10. 10 times 0.5, that's 5. You put it right there. 15 times 0.5, you put it right here, 7.5. You continue that pattern for each X value. After you have the predicted value, then you need to find the difference, the residual value. The residual is your observed value, Y, minus your predicted value, Y hat. So this case would be 3 minus 2.5, which would be 0.5. You do this for each value, 4 minus 5, which would be -1. You continue to do that. Today what we're doing in class, the goal is that you can make a residual plot, okay? And how you make a residual plot, for those of you who are working on it individually, I'm going to see if you can do it on your own. But let me just explain. So we just went through all of step 4 yesterday, our observed Y minus our predicted Y. In quadrant 1, which is your quadrant right here, and quadrant 4 is where your residual plot will go, okay? So for example, on your x-axis, this is going to be the x data from number 1. So 5, 10, 15, 20, all the way to 30, okay? 5, 10, 15, 20, 25, 30, okay? On the y-axis is going to be our residuals. So for example, our first residual was 3 minus 2.5, so that's 0.5. Our next one was 4 minus 5, that's -1. So you're going to want to look and you're going to want to figure out what your scale should be based on your residuals. So the first one is 0.5, 1, 1.5, 2, 2.5. -0.5, -1, -2.5, so on and so forth. So plot your X values right now on number 1 and your Y values, your residuals, on the Y-axis. When you plot it now, okay, your coordinates are going to be your X value and your residual value, okay? So if I look at my worksheet, my X value is 5, my residual value is 0.5, okay? So on the worksheet here, I would go to 5, which I should have labeled, and 0.5, and put a point there. The next one is 10 is my X value, and my residual is -1. So I go to 10, and then I go where I have -1, and I put a point there. After you're done with the residual plot, you have to decide, what's the point of that? Well, that's this screen. When you have a residual plot that looks like this is a good thing. There is no pattern like going from lower to higher, or a U this way. This is an appropriate residual plot. So that means my least squares regression line is appropriate because there's no pattern in the residual plot. Here, though, there is a pattern. It's a straight line, okay? So my least squares regression line is not appropriate. Again, here, it is not appropriate. I have a U shape. And again, here, it is not appropriate. I have a U shape. This goes back to the very beginning. In class, I'm going to talk about, hey, we have these tools. Are they appropriate? I have a scale. Is that an appropriate way to measure my weight? Yes. Is it an appropriate way to measure a baby? Probably not. A baby, I can't just lay a baby on a scale like this. I need a special infant scale. A ruler. Is this an appropriate way to measure my piece of paper? Yes. Is it an appropriate way to measure the length of my telephone? Yes. Is it an appropriate way to measure my height? No. There's something better out there. So residual plot tells us is if there's something better out there. We're looking at that least squares regression line. We want to know, is it an appropriate measurement tool? And that's how we do it. Hopefully this helps you get started. Thanks, guys.